In this video, we'll generate the binomial series dataset of 1 over 1 minus x to the power n plus 1, where the value of n will be from 0, 1, 2, and 3. So here's the dataset. So array formula, 1 over 1 minus x to the power n plus 1. And we'll chart this. Using scatter chart. And show the trend line. Polynomial to the 6th degree. And show it at the bottom. So the equation will be our label. Here's the polynomial trend line to the 6th degree and its trend line. So at n equals 2, so that's the polynomial. And we generate the Taylor Maclaurin SERIESSUM expansion, where y equals a times x to the power k, and a is the coefficient combined n plus k, comma k, and the value of k is from 0 to infinity. So 0, 1, 2, 3 to infinity, but we can reach 12. So our Taylor Maclaurin series sum will be array formula series sum of the x values that's raised to the power k, where k starts from 0 in interval of 1, and the coefficient will be this range. And we show the trend line and trend line equation. Polynomial to the 6th degree, and show the equation. Now we can continue with the coefficient, which is equal to array formula combine n plus k, n plus k, comma k. Sure. And we'll calculate these regression coefficients of the trend line equation using the LINEST Polynomial Regression. To do that, we complete the 1, comma x matrix. We begin with the power. This is transpose from 0 to 6 because it's the 6th degree. And we complete the 1, comma x matrix. So array formula of the x values raised to the power 0 to 6. Now that we have the 1, comma x matrix, we can enter the LINEST of the binomial series itself, data y and data x. And we'll also enter the LINEST of the Taylor Maclaurin SERIESSUM expansion, so LINEST, data y and data x. Now that we have the regression coefficients, we'll compare it with our trend line polynomials and the expansion coefficients, starting from 0. So our regression coefficient match to our trend line 1 at x, that's also 1x. This one is all 1x squared. And this is 0.918x cubed, 0.921x cubed, 0.88x to the fourth, and 0.891x to the 892x to the fourth. This is 1.62x to the fifth and 1.61x to the fifth, 1.7x to the sixth, and 1.68x to the sixth. Our expansion coefficients are all 1, which is different from our regression coefficients. At n equals 2, our expansion coefficients are from 1 to 13. Our regression coefficients are, they're not the same, but they still reach to 13. The coefficients will match to the trend line equation. So that's 1. This is 2x. This is 2x. This is 3x squared. And this is 3.26x cubed, 3.3x cubed, 3.87x to the fourth, and 3.93x to the fourth, 11.5 to the x to the fifth, and 11.3x to the fifth, 13.9x to the sixth, and 13.7x to the sixth. At n equals 2, this is our expansion coefficients. They differ here, and this value will be at the 8th degree, and this values will be at the 10th degree. Our coefficients match to our trend line. That's 0.998, 3.11x, 6.3x squared, 6.28x squared, 6.15 or 6.16x cubed, and 6.46x cubed, 8.54x to the fourth, 9.06x to the fourth, 48.7x to the fifth, 47.1x to the fifth, x to the sixth, you have 66.6 and 64.24. At n equals 3, our coefficients, that's 0.991, 4.46x, and this one is 4.4, 11.3x squared, 11.1x squared, 5x cubed, and 6.72x cubed, 7.63x to the fourth, 10.69x to the fourth, 161x to the fifth, 152x to the fifth, 243x to the sixth, 230x to the sixth. And our expansion coefficient, they match at the 0 degree. You also match at the first degree, almost. At the 10th degree, the second degree, they almost match. At the third degree, there's a difference now. So this x to the fifth, they're still part of the fourth degree. And x to the fourth, you have 7 still here. And 151, 161 should be around 8 degree. And 243, 229, they're around this degree. X to the 6 degree. This completes the use of the Taylor Maclaurin SERIESSUM to generate the dataset of the binomial series, LINEST Polynomial Regression to generate the trend line and trend line equation.